Morning. Today we are going to see something on this four-cylinder diesel engine. Right? Do you know what is this? It's an exhaust pipe. So we have an L&T XGM problem statement. So do you aware of L&T company? Yes. So that company has given so many problem statements. In the problem statement, they have given a challenge that this exhaust pipe is getting corroded due to temperature and moisture. Usually, when the diesel engine is running, the burned diesel of the exhaust is coming out through this particular pipe. Right? So, due to that, this pipe gets corroded. So, what is corrosion? Any idea? Formation of oxide. For example, if you have copper, it forms copper oxide. If you have aluminum, it forms aluminum oxide. So it is a deterioration of this particular metal. So the thickness of the pipe gets deteriorated due to oxide scale formation. We call it as rust or corrosion. Right? The phenomenon that happens within this is corrosion. Right? So they are asked to develop a material that can extend this corrosion, right? And we have to continuously monitor whether corrosion is happening or not through a map. So what ideas do we have? Like what are the things we can do to find a new material? We have to go with the thinking process. Right? We have to apply our DD principles and find an idea to replace this material. So, if the silencer pipe lasts long, or if the exhaust gas going outside is again recirculated into the engine, into some of the engines, right? So that we call it as turbochargers. Right? This turbocharger's efficiency is to improve the performance of the engine. So the turbocharger efficiency again depends on the material and the volume of exhaust. Understood? So that is the challenge given in L&T XGM, and we have to develop POC. I think you are aware of proof of concept. So you have to develop a material, and then you have to develop a new material that will last long, and you have to develop a software to maintain or monitor this pipes, thickness or corrosion rate, right? That are all the things we have to do. Okay? I hope you understood about this exhaust pipe. So normally in 2 years, in Yamaha, Honda, we have exhaust pipe. Are you aware of that? So what actually the purpose of this muffler? It is technically called as muffler. So the exhaust pipe muffler will have baffles. It's called a round plate that is being spot welded everywhere, and the excess noise coming from the engine, the cracking noise. Usually fire burns the cracking noise. So the fuel burns with the cracking noise. It comes out of that particular exhaust pipe, and the sound is being resonated between the baffles. The sound is sent forth, and then it is being reflected back, so that the sound gets reduced when it comes out of that. That is the purpose of baffles. Right? Understood? So, again, a lot of process involves building a muffler for two-wheeler engines. It involves pipe bending process, and you have to use sheet metal bending, and then you have to weld the baffles. So, a lot of process involved. Again, there is a possibility of corrosion due to various manufacturing processes involved in the muffler. So we have to think about all these things and plan a new material and continuous monitoring system. That is the challenge. Shall we do it? So to take this problem further, we need to have knowledge of materials, metallurgy, and we need to have knowledge of testing. Right? So we have have something called as American Society for Testing and Materials, ASTM standards. So any material you select for engineering purpose or any functions of any engine, so it has to be tested with ASTM. So only after that, because this material is going to serve an engine, and that is the major function of that material has to last long. Durability is expected and the quality of the material is expected. So we need to test with ASTM standards. Okay. So before that, you can also go for coating materials. Okay. So any material that is being used in the environment of moisture or environment of temperature, we can either use parent material or we can go for coating the material. Like when we have rain, we are putting raincoat. Right? The same way, we can apply coating inside of the pipe, and we have several coatings: ceramic coating, nano material coating, and today the purpose of the field of nanotechnology has come into picture, where you can see lotus leaves, there is no water sticking on them. That is because of, not because of nature, but because of the nanopores available in the leaf. That is why it is not sticking to that. So in that way, we can tackle this problem, and